In this video, things are going to start to get exciting where we're looking at probability using combinations. So one of the biggest applications of this is looking at probability when it comes to hands of cards. And so we're going to use combinations to look at that. The reasons that we need to use our knowledge of combinations from before is because the number of possibilities is too high to count by hand or by writing them out. So we have to use some further math to do that. So here you have a hand of 5 cards, and you want to find the probability that all of your cards are going to be red. So we need our number that all cards are going to be red, and we're going to divide by our number of 5 card hands. This is where we need to use combinations. So on top, we've got 26 red cards to choose from, and we're choosing 5. Order doesn't matter. Ace, 2, 3, 4, 5 is the same hand as 5, 4, 3, 2, and ace. And on the bottom, we're just choosing a 5 card hand, so 52 cards to choose from, and we're choosing 5 cards. This is going to give us 65,780 over 2,598,960. Dividing that on your calculator is going to get 0.0253. The next card hand that we're going to take a look at is getting 4 of a kind. So that means 4 cards that are all the same. So here we're going to have our total on the bottom here. We are still choosing 5 cards. So we've got, our number is the same as before. Let's write this here. So we would have 52, and we're still choosing 5 cards, but our number of ways that we can get 4 of a kind is there are 13 possible hands that we can get that are 4 of a kind. So that means that we'd have 13 out of 2,598,960, which is going to give us an incredibly small percentage. So 0.0000005 chance of getting 4 of a kind. The next hand that we're going to look at is 2 kings, 2 queens, and 1 jack. So 2 queens, 2 kings, and 1 jack. So the first thing that we're going to look at is the number of ways that we can choose 2 kings. So we've got 4 kings, and we're choosing 2. We're going to multiply the number of ways that we can choose 2 queens. And then finally, the number of ways that we can choose 1 jack to figure out our possible combinations of that hand. And then on the bottom, we still have our same 52 choose 5. When we multiply that all together, we are going to get 0.0000055, slightly higher chance of getting 4 of a kind, but not much. The next hand that we're going to look at is getting a full house, which is 3 of a kind and 1 pair. So for example, let's take a look at 3 kings and 2 eights. So how many ways can you get 3 kings? Well, that would be 4 choose 3. Then we're going to multiply the number of ways that we can do 2 eights. So we've got 4 choose 2, same as before. Now this equals 24 possibilities for 3 kings and 2 eights. Now we need to multiply by getting that for all the different suits. So we're going to multiply by 13 first, because once we choose our 3 of a kind, we've got 13 suits in total that we can choose from, or we've got 13 cards that we can choose from. Then we're going to multiply by the number of ways that we can get a pair, which is going to be 1 less than 13, because we've already used one of our numbers as 3 of a kind, so there's no way to get 3 of a kind and a pair from the same suit. So this is going to give us our numerator, so 3,744, and we're going to divide by the number in a 5-card hand, same as our previous questions, which gives us about 0.144%, which is actually quite a bit higher than examples B and C. The last one that we're going to look at is what if one card is a jack? So I know that for at least one card to be a jack, I can use the complement property to calculate this, because it's going to be easier to isolate the hands where I don't have a jack. So I'm going to do 1 takeaway again over my hand here. And I'm going to choose, so not a jack, this would be, I would have 51 cards to choose from, and I would choose 5 of them. Oh, I guess I should take out all 4 jacks probably. So this would be 48, choose 5. So I'm only choosing from the rest of the jacks. So 48, choose 5. And then I'm going to divide by my possible number of 5-card hands. And then I would do 1, take away that answer, which is here for that intermediate step, which gives me a chance, well, about 34% chance that my hand is going to at least have 1 jack. So we're using combinations here because our number of possibilities is just too great to count by hand.